Hello, my name is Gabe. For this problem, we're asked to evaluate this surface integral, the integral of x minus 2y plus z, where the surface is given by z equals 4 minus x, and x is between 0 and 4, and y is between 0 and 3. Now, the way that we're going to go about evaluating the surface integral is by using this idea here to rewrite the integral. So, something that we want to notice first is, well, how are we going to replace this z with this g of xy? And that comes from our surface. We have z is equal to 4 minus x. So this right here is what we're going to use in place of our g of xy. So g of xy is getting replaced with 4 minus x. And we also see that we have to work with the partial derivative of g with respect to x and the partial derivative of g with respect to y. So let's go ahead and find each of those right now. So the partial derivative of g with respect to x is just -1. And the partial derivative of g with respect to y is 0. So now we have our g of xy, our g of x, or our g sub x, and our g sub y. Now we can go ahead and we can substitute these into this equation here, so into this integral here. So our integral over the surface S of x minus 2y plus z ds is going to be equal to the double integral over a region R, which ends up being the projection of this surface into the xy plane. And since this region is given like this, we actually can go right ahead and we can write down what the region is in our integral. So x is going to vary from 0 to 4, and y is going to vary from 0 to 3. So we have the double integral, x varying from 0 to 4, y varying from 0 to 3. Now we're going to replace our function f of x, y, z, this x minus 2y plus z, with this function of x, y, g of xy. So we'll have x minus 2y, and we're replacing z with 4 minus x. And here, we're going to multiply this by the square root of 1 plus, here we have our partial derivative of g with respect to x squared. So that's going to be a -1 squared, which is 1. And then plus the partial derivative of g with respect to y squared, which is 0 squared, which is 0. And then we have our dA, which in this case, I said we're integrating with respect to x first, and then respect to y. So, looking at this, we see that what's under the radical is just the square root of 2. So it's a constant, so we can imagine pulling this out in front of the integral. And we have the integral from 0 to 3, the integral from 0 to 4. Here we have an x minus x, so these two x's are going to cancel. And what we're left with as the integrand is -2y plus 4, and then dx dy. So here, let's go ahead and let's integrate with respect to x. So this is going to be the square root of 2 times the integral from 0 to 3. If we integrate this with respect to x, we'll have a -2xy plus 4x. This we'll want to evaluate from x equals 0 to x equals 4. and then integrate with respect to y. So this is equal to the square root of 2 times the integral from 0 to 3. Well, we know that when x equals 0, this is going to be 0. So all we need to find is when x is equal to 4, which tells us that this is going to be a negative 8y plus 16. So now all we have to do is we have to integrate with respect to y. So this is equal to the square root of 2 and evaluating this integral with respect to y, we'll have negative 8y squared divided by 2, or negative 4y squared, plus 16y. And we want to evaluate this from y equals 0 to y equals 3. So what we're going to have is we're going to have square root of 2 times, well, if we substitute y equals 3 in for y, we'll have negative 4 times 3 squared, or negative 4 times 9, which is negative 36, plus 16 times 3, which is 48, and if we substitute in y equals 0, we're going to have 0 plus 0, so I'll be subtracting off 0. So now what we end up with is our surface integral is equal to the square root of 2 times 12. Or if you would like, you can write this as 12 times the square root of 2. Thank you.